Welcome back. We're going to talk about the second topic in Unit 1-2, which is for loops and repetition. And in this discussion, we'll talk about how we structure an element in a program that can repeat a task a given number of times. So let's go ahead and get started. We can write our programs to repeat tasks, as I said, but the idea here is that we have a set of commands that really don't change, but we want to be able to execute them many, many times without having to type them over and over again in our program. It makes your program really hard to read and hard to follow and harder to troubleshoot later. So if we want to do something specific a given number of times, we use what's called a loop. There are two kinds of loops. There are definite loops and indefinite loops. We're going to be talking about definite loops today. So for example, if I want to give the instructions, let's say to a robot, take 10 steps due north. I could do that, but that's really thought of as repeat 10 times, take 1 step due north, right? Or if I don't know how many steps it's going to be n number of steps. I can say repeat n times, take 1 step due north. You did something like this in programming exercise 1.1, where you modified the chaos program to prompt the user for the number of chaotic values to display, right? And you modified that one value in the for loop. It said for I in range 10, and you changed it to say for I in range some variable like n, and above that, you would have used an input statement to get that value from the user. So if the number of times the thing needs to be done or repeated is known, then that's what's called a definite loop. We know it's going to be this variable, n, whatever number is in there. We know it's going to be 5, whatever it is, it's a definite loop. So when we set up a loop, we sometimes need to repeat either one step or many, many steps again and again. And loops will help us to write programs that are not redundant. For example, if I want to print the even integers between 0 and 10, including 0 and 10, I could use 6 print statements: print 0, print 2, print 4, print 6, print 8, print 10. But that's 6 lines of code, right? 6 different print statements, and I've hard-coded the values in there. And that's really kind of messy. What if it's not just from 0 to 10? What if it's from 0 to 100? Or what if it's from A to B, and A and B are values that are entered in by the user? We don't even know how many print statements we'll need in that case. But if we use a loop, then what we do is we eliminate these repetitive print statements, and instead we set up a loop that increments the value of some counter, let's say the variable I. I like to use the variable I, a lot of people do, I for increment, right? That's going to increment the value of a variable called, let's say, I from 0 to 5. So it's going to go 0, 1, 2, 3, 4, 5. And then inside the loop, you just display 2 times I. Now, does it matter what I is incrementing up to? It could be incrementing up to 5. It could be incrementing up to 500. The length of this program doesn't change. It's 2 lines long. It's just increment the value from 0 to 5 or from A to B, and then display the value as it increments between the two. So we'll learn as we work with for loops that there's a lot of ways to do this incrementing. It could be from 0 to some number. It could be from A to B, and those could be any integers. You could even tell it a step. So go from 0 to 10 by 2's. You could do that as well. And then, of course, your code would be a little different. But using this 2 lines, we've replaced these 6 lines of 6 different print statements with just these 2 lines. Now, this is pseudocode, so we need to know how to set up the loop to increment the values from 0 to 5. But once we know how to set up the loop, we're good to go. All we have to do is set the loop and display 2 times whatever this variable is as the loop repeats. All right, so it cuts down the size of the program, makes it easier to troubleshoot. When Python starts a loop, it knows exactly how many iterations or repetitions it's going to do. And you'll hear iterations or repetitions a lot as we talk about Python loops. So while it might say repeat n times, Python knows what n is, so it knows how many times it's going to repeat. You also might say repeat 5 times. and then you know it's going to be 5. So I set up a for loop with for and then a variable, some kind of variable. I like to use I when it's a counter type loop, like counting from 0 to 5, in a sequence. Now the sequence can be almost anything. The default one, the one that most people use, is a function called range and then a number. So for I in range 10. That's from the chaos program you did in programming exercise 1.1. Then the body component is indented. Remember, anything that ends in a colon, like this for statement, anything that ends in a colon, everything below it should be indented so that Python knows what is included, in this case, in the for loop. What does it repeat that many times? And that's what we use the indentation for, is to indicate the body of the for loop. The variable in the for loop is called a loop index. The loop index will take on each successive value in the sequence. If the sequence is 0 through 5, then every time the loop repeats, the variable will be replaced with the next value in the sequence. We can use for loops though, and we'll look a little later this semester. We can use for loops with any type of sequence, including a string of characters, a list of values, a lot of different things. I think you'll find as we go through the semester, we're going to use for loops for a lot. They're sort of the hammer. If you think about tools in a toolbox, they're the hammer of Python. We use them for all kinds of things. So for example, if I say for I in range 4, let's take a look at that. Let's take a look at that in, here we go, in idle. If I say range 4 like this, it's going to give me this, if I say for I in range 4, what range 4 gives me are values starting at 0, going up to but not including 4. So 4 values, 0, 1, 2, and 3. So if I print I, then I get 0, 1, 2, and 3. So in this case, for I in range 4, print I, it's going to show me that each time my for loop repeats, I was given the next value in this sequence, and range 4 gives me the sequence 0, 1, 2, and 3. 4 values starting at 0. It is hard sometimes to remember that these sequences, by default, unless you specify otherwise, they'll start at 0. So it's not going to go up to and including 4. It's actually going to be up to and not including 4 in this case. But I could also do something like for odd in, and then remember this structure. This structure is a list. It's a simple way to organize some data. We'll see a lot of examples of lists as we go forward. We're going to work with lists so much this semester. You'll have lists squirting out of your ears. So many lists. But for odd in, and then this is my sequence. So what does that mean? That means that every time this loop repeats, the variable called odd is going to be given the next value in this sequence. And I want it to print odd squared, odd times odd. So the first time through it prints 1 times 1, and we get 1. Then 3 times 3, and we get 9. Then 5 times 5, and then we get 25. So we've set up this sequence as my sequence for my for loop to substitute into that variable called odd. So it doesn't have to be I. It could be any variable that you'd like to use, and it doesn't have to use the range function. It can use any sort of sequence. And like I said, this semester, we'll play around with a number of different types of sequences and lots of different possibilities. So let's take a look at this one. How many times will this for loop execute? For I in range 100, %6? What does that even mean? Let's take a look in idle and let's see what that means. Let's come over here and pop over to an idle terminal. What is 100 modules %6? It says it's 4. That 6 doesn't go into 100 4 times. You know what 6 goes evenly into? It evenly goes into 96 with a remainder of 4. So this is actually the modulus function. This is the function that allows us to do division and collect the remainder. So if I did, for example, 100 integer division by 6, it's going to tell me 16. And in fact, 6 times 16 is 96. So 6 goes evenly into 96, but not evenly into 100. So when I do 100 modulus 6, it figures out what number 6 goes evenly into up to 100 if it goes into 100. In this case, it doesn't though. It goes into 96 and has a remainder of 4. So this, like an algebra equation, we do what's in the parentheses first. This gets evaluated to 4. For I in range, 4. C equals I to the power of I. So range 4, what's the first value for I? This is like I in range 4, right? So 0, so C equals 0 to the 0 power, print C. But this is not asking what gets printed, it's saying how many times will this for loop execute? Well, 4. It's going to execute 4 times. That's what's going to happen. That's a pretty common type of question you might see on a quiz or something. But it is important to understand how this algorithm works. It's going to repeat this loop 4 times, and it's going to, in this case, it's going to be displaying each of those values to its own power, 0 to the 0 power, 1 to the 1, 2 to the 2, and 3 to the 3, right? All right. So when we set up a for loop, if we know it's going to execute a certain number of times, is it possible that if I set up a for loop that's supposed to loop 100 times, is it possible I need it to stop after 70? Yeah, it's possible. And there is a way to stop or break out of a loop in the middle of its iterations, and we'll talk about that. We'll talk about that a little bit later. There's also a way to skip everything inside the loop and go up to another iteration immediately. And we'll also talk about that a little bit later this semester, but we definitely want to get the basic concept of a for loop. So I encourage you practice this. And in fact, in your code lab exercises, you have a couple of dozen for loops to write, a number of different variations. Take a look at what's in the textbook. There's examples there of writing for loops where you're not incrementing by 1 every time. For example, you might increment by 2 or 3. So for I in range, let's say from 0 to 20 by 2s. And then let's just print I and see what we get. So it increments by 2s. And notice I said go from 0 up to, but not including 20 by 2s. So 0 to 18 gets printed. There's a number of different variations like this that you'll see. And it's just a matter of playing with it and working with it. All right, take the quiz that goes along with this lecture, and I believe there's one more. All right, have a great day.